Hello, and welcome to Synchronized Science, where we break down the latest breakthroughs in technology. Today, we are looking at a new AI system called AC-Foley that is changing how we generate sound for silent videos. Have you ever noticed that AI-generated sounds often feel a bit generic or don't quite match the textures on screen? Usually, these systems rely on text prompts, but describing a sound with words is incredibly difficult. For example, the phrase metallic clang could mean a hammer hitting an anvil or a heavy chain falling on the floor. Researchers found that this textual ambiguity leads to sounds that just don't feel right for the specific scene. To solve this, they developed AC-Foley, which uses a reference audio clip to guide the generation process. Instead of just telling the AI to make a dog bark, you can provide a recording of a specific Chihuahua or a Great Dane. The system then takes the soul of that reference sound and perfectly syncs it to the movements in the video. This allows for incredible timbre transfer, where the AI can even take the roar of a lion and replace it with a cat's meow while keeping the timing perfect. It also enables zero-shot generation, meaning the AI can create specific sound effects it wasn't even trained on, like a gunshot with a silencer. The researchers achieved this by creating a complex multimodal transformer that looks at video, text, and audio all at once. One of the biggest challenges in this field is making sure the sound doesn't just start and stop randomly, but actually matches the visual action. Simply overlaying a sound often leads to a pasted-on feel where the timing is just slightly off. To fix this, the team used a clever two-stage training strategy to teach the AI about timing. In the first stage, they gave the AI overlapping audio and video so it could learn the basic features of the sound. In the second stage, they used non-overlapping sounds from the same video clip to force the AI to learn how to adapt the sound's characteristics to new visual movements. This results in footsteps that sound different depending on whether the person is walking on wood, marble, or gravel. In tests, AC-Foley significantly outperformed previous models in both audio quality and how well it synced with the video. Human participants in their studies preferred AC-Foley's results over 83% of the time when it came to acoustic fidelity. The system is so flexible that it can even work with reference audio of any length. This is a huge step forward for professional sound designers who often spend hours manually syncing effects to footage. Even when the AI isn't given a reference sound, it remains highly competitive with the best existing video-to-audio models. Let's recap the most important takeaways from this research. First, using actual audio samples as a guide is much more precise than using text descriptions alone. Second, the two-stage training method is key to making sure the AI understands the rhythm of a scene. Third, this technology allows for a high level of creative control that was previously impossible for AI. Looking to the future, this could revolutionize the way movies, video games, and social media content are produced. We might soon see tools that allow anyone to be a professional Foley artist with just a few clicks. It could also make virtual environments feel much more immersive and reactive to our actions. This research bridges the gap between the visual and auditory worlds in a way that feels natural and convincing. Thank you for watching this summary of AC-Foley on Synchronized Science.